Hello students, so in this lecture we are going to discuss about capacitive sensors. Now, capacitive sensors are mainly used to detect any sort of displacement or motion. Uh, they can uh, be associated with other forms of change of parameters like pressure, temperature, uh, but their ultimate need they are used for detection of movement or sensors, movement or displacement. Now, this displacement sensing occurs due to change in capacitance C, and which can occur due to either the movement of the capacitive plates, that means the distance between the plates, this is T, if it changes, this one, or if the dielectric between the plates uh, it changes, so that means this epsilon value changes. These are the two ways by which the capacitance may change and can be used in detection of motion. Now, there are different configurations of capacitive sensors. If you are using a single capacitor, it's called a monopolar. If you are using if you're using two capacitors, then it's called differential capacitance sensors. And if you are using four capacitors, then the configuration is called bridge configuration. Now, whenever you have two or four capacitors, either in the form of differential capacitor system or a bridge capacitor system, uh, half of them will be fixed and half of them will be variable. Like in the case of a differential, which consists of two capacitors, one is kept fixed and the other one varies. Similarly, in the case of a bridge capacitor, two are kept fixed and two vary. The bridge capacitors are formed like this: four capacitors in this fashion, with the dielectric between them. These are the dielectric and these are the capacitors. So in this case, the diagonal 2 may vary and the other diagonal 2 is fixed. Similarly, in the case of double capacitors, one of them will be kept fixed and another will vary. So let's take an example where we are using a differential capacitor. Like in this system, where three plates are being used, and these three plates are creating two capacitance. So the first capacitance is created by this plate, plate 1 and plate 2. So you have a capacitor formation here, and the second one by second and the third you have a capacitor formation here. However, we have kept the distance between the plates same, which is D. Now, in this configuration, if we associate a sinusoidal voltage to one of the edge capacitors, like here we sine omega t, the AC voltage, and we phase shift with the help of an NOT gate for the phase shift, and provide minus V sine omega t voltage at the other edge plate. Here we will get the output voltage as 0 because they will cancel each other. This is the pristine condition. Now here, if the middle capacitor it shifts, that means, for example, say it goes close to the third capacitor, so by an amount x, so this is the displacement, So this displacement will cause the change in capacitance. Like the first capacitance will be epsilon A by d0 plus x, and the second one will be epsilon A by d minus s. These are the two capacitance, and also in this case what has been observed is that the output voltage is no longer zero, because they are not cancelling each other, they are adding up, and the output voltage V0 in this case, where it has moved down towards the lower capacitor, is equal to this value, where relative change in capacitance versus the original capacitance is factor, and the change in distance is a factor. Now, from this velocity or the output voltage, we can find out how much displacement, or we can use it in the form of a motion sensor. The higher is the signal voltage value, the higher is the displacement that has taken place. Another important aspect is that based upon the phase, that means the sign change, we can identify whether the plate has moved up or down. So phase change also provides you the direction of the movement.